Okay, so now we're switched over and we're doing AT188, the scan tool diagnosis / Snap-on Solus stuff. And I just wanted to have a little bit of time to connect with you guys and let you know kind of what's going on, okay? And what do we have to do? I don't have anything really due for you right away, because remember, the whole idea is that this class was supposed to be second 8 weeks. So I'm trying not to kill you. And I know I have several people that are in both. They're in the 181 and the 188. And I'm, trying to be respectful of your time and schedules. That being the case, I know I have some folks that are only in 188, and you're probably chomping at the bit to do some stuff. And so I want to get you doing stuff. I mean, we have the time. Let's do it. So I have a whole bunch of materials and things for you to do. Okay. So with that, just a couple things. If you ever are in one of my Canvas classes, you want to know, hey, what's coming up due when? You always click on the calendar, and that'll show you what's due. There's nothing due for a while on this class because I'm trying to, give folks who are in the other section time to get their 181 stuff done. This particular class, I've color coded it on my chart here, green. If we look over here, so this is my green color code. And so you see none of this stuff is green yet. In fact, I have to get out of February and I got to go over here to March before I start seeing some green pop up. So you guys technically don't have anything due for a while, but I know you are, if you're here with me right now tonight, you're one of those A+ students and you want to get going on stuff, I figure. So let's jump into this thing and let me show you some stuff that you can get started on. So I'm going to go back to our course, our 188 course. And I like to build these classes so everything's available to you in the modules. Yeah, if you want to go to discussions, you can hot link over to discussions. But I try to make sure that in the modules thing, you have everything you need. So we got the syllabus there. We got the safety test stuff. And then a few weeks ago, actually, some of the materials we were going through was this beginning weeks and scan tools information. Now, what I've done since then is I've started to add on all of our Snap-on training, okay? So I wish I could check out $3,000 Snap-on Solus scan tools to you, but the school district's not going to let me do that. So the best thing I can do is at least give you all the information. I forgot that web page link's a little funky, so you got to click it. In fact, we'll fix it here in a second. But it takes you to the Solus. What you'll notice is that Snap-on doesn't, they don't actually put the prices of their stuff just on the website. It's not easy to find. This is about a $3,000 tool. And there's a lot of stuff I like about it. I wish it was less expensive, but it has some nice features, especially with the troubleshooter. It starts very quickly. It's pretty bulletproof little tool, really. You can hook it to a computer, although that part's a little clunky. Anyways, so I put the link in there for you. We'll go back to our Canvas class. In fact, this irritates me. We're going to fix this real quick because we can't have broken links going on. We'll do that, and that'll fix that. All right, so I've loaded all the Snap-on stuff. So if you guys want to get started on the Snap-on stuff, this stuff's pretty good. And I have Mr. Snap-on, is what I call him, in the videos going through stuff. So we've tried to break these videos up into pretty short segments, and you can play it in here or you can blow this up. You can see that this video's here where we get all the codes here for you. All right, so you can see that this one's broken up to 7 minutes and 58 seconds. I tried to break them down.
We had a code and went to look at the data, but all the data appeared normal at this time. Cap codes menu.
So we got Mr. Snap-on. He kind of runs that Snap-on scanner through its paces and shows you what it can do. Okay, and it can do quite a bit because it has the ability to simulate the factory scanner and also act as a generic scanner. So what that means, and I don't know if you guys can see it really well on your screens, but you'll notice this says 2001 Chevy Tahoe four-wheel drive. What it's doing is simulating the factory scan tool in its software. Okay, now the factory scan tool during that period of time, well, that was this guy right here. That was the Tech 2. Okay, this was made by Beatronics. This was an awesome tool, and this was the tool GM had at their dealerships at that period of time. Well, the Snap-on can emulate that, and it's a lot more than just a generic OBD2 scanner. But what I want to stress in this class is there's a lot of diagnosis that you can do with a generic OBD2 scanner. So you don't necessarily need a Solus. You can do a lot of figuring stuff out with a very basic scanner. And so that's how we've kind of shifted this class is let's focus really hard on the basics and what we can do from that OBD2 generic data. And from there, we can kind of branch out into the factory stuff after that, okay? So I went ahead and opened up all the Snap-on training so that you guys who are go-getters, if you want to get started on that stuff, you can. Now remember that I also made that Snap-on stuff, that certification is not required. It's an optional thing. It's 50 points. It's definitely good if you're like, oh man, I'm never going to own a Snap-on scanner. Well, then that's what it is. I would still say that the Snap-on scanner platform, whether it's a Solus or a Ethos or a new Modus, like they're all kind of using the same operating system. So if you go through this Solus training, if you picked up an Ethos, you would know how to use it. Okay. So I have Snap-on training part 1, Snap-on Solus Ultra training part 2, all loaded in there. And then I have some stuff for advanced diagnostics that I put in here. And this is the real cool stuff that we're going to get into really in depth, like as we move into March and April. But again, I wanted to open stuff up. So if you guys want to start looking through this stuff, that you can start messing around with some of this stuff like volumetric efficiency calculations. And these are all things that you can do with a generic OBD2 scan tool like you have with a ELM 327 device, okay? But I will say to really understand how to get the most out of any scan tool, right? It still takes us back to you need to understand onboard diagnostics in general and the particulars to OBD2, okay? And so that's where I wanted to spend a little bit more time tonight. So none of this stuff is due yet. I did want to say that I have some of these interfaces at the college now. And like I told my last group, if you're like, hey, I don't want to buy an interface, can I check one out? Send me an email and we'll set it up so that you can check one of these out from the school, okay? So you can download the free app with your cell phone, and it doesn't even have to be a new phone. It could be, an old burner phone you have from a couple years ago or something. It doesn't have to be something great. You can get the app for free on your phone, and you can get the interface. And so really all you need is like an old phone and access to a 96 or newer vehicle, and you'll be able to do a lot of learning with that, okay? So let me know, send me an email if you want to check out an interface from the school. And you don't have to use this particular one. There are several different ones that conform to the ELM 327 protocols. And the reason I picked that one was because it had good app coverage and support with like free apps and different things, okay? Now, if you have your own scan tool, maybe you have an OTC scan tool, maybe you have an all tech, or, you know, like, I don't, you know, if you have a scan tool that can pull generic OBD2 data, that's all you need. So I also don't want to nickel and dime you and tell you you have to have the 327. No, you don't. All I want you to do is be able to pull OBD2 generic scan data. And because my job is, I'm going to get you to where you can get the most amount of diagnostic information from that OBD2 generic data. And then if you have anything else available on top of that, whether it's the Snap-on or any manufacturer supported PIDs, that's going to be bonus. Okay. What I find is there's a lot of techs out there that aren't even getting the most out of the generic scan tools. They're using them as just a code reader. I know guys who've been using, you know, a $6,000 Modus, and they're using it as a code reader. And it's like, dude, you're not even using that tool for half of what it can do. So anyways, that's our goal. So we're going to keep going through here, and we're working through this scanners and generic OBD2 presentation 1. I'm going to change my screen share, and we're going to jump back into that thing. So let me see if I can get that guy opened up. There we go. And of course, we're recording, so I will at some point get this loaded up to YouTube. It'll be a private link, so the folks that weren't with us tonight can jump in. They can watch this video and get get kind of caught up to speed and go in the right direction. There's a lot of terminology that I think is important, so that, you know, we're talking about the right stuff as we go through vehicle diagnostics. So with that, I'm going to change my screen share again and get this thing set up a little bit better. There it is. Okay. And we started this thing a couple weeks ago. I don't know if you guys remember, but a few weeks ago we were jumping in this presentation, and this is the evolution from BAR's old OBD2 update, and I've just kind of updated it over the years. You got to remember that when OBD2 came out in 1996, right? Like in the industry, we were stressed out about it. We were like, oh, what's that going to be? I mean, we were nervous about it. And so one of our first updates as smog techs, because in the 90s, right, like that smog check technician was like usually the most senior dude in the shop, guy or girl, right? That person was the one of the top people in the shop. BAR said, okay, well, the first thing we want to update all these folks on is what's going on with OBD2. Okay. Well, that really built upon our knowledge of OBD1, which included a lot of things of like, how do different sensors work? How do we test those circuits with our meters, right? And other various test equipment. Right? But now we had all this extra onboard diagnostic capability, and how do we leverage that? So let me clear those drawings out, and we'll keep stuff moving forward here. So I have the question there is how would you test the circuit? But let's back up a little bit. Let's look at what we can see from this very simplified diagram of a temperature sensor circuit, a resistor that varies his resistance. See how this is the symbol for a variable resistor? A resistor that varies its resistance with temperature is called a thermistor. And just a fun little factoid, most of these thermistors that we use in our vehicles happen to be NTCs, negative temperature coefficient thermistors, meaning that the hotter they get, the lower their internal resistance goes. All right, well, this is how this thing would be wired up. And you can see, like, if I was going to hook up my DVOM or DMM, right, to measure volts, I would hook them up. I'd measure the voltage drop across that thing, or I could measure his resistance. And but anyways, that's how I would hook up my meter. And you notice that my meter is hooking directly to the sensor, right? Notice that my scanner my OBD2 scanner, or generic scan tool as it's written here, that goes to the DLC, the data link connector, 16 pin, which was a standardization for OBD2. It goes to the data link connector, and what it receives is serial data, ons and offs, ones and zeros, interpreted data from the computer is what gets sent to your scan tool. So what does that mean? Well, that means that this thing could have whatever resistance it is. And let's say the temperature of the engine is really at only 100 degrees Fahrenheit, okay? But this sensor is messed up. And so the voltage drop across the sensor is very low. And this thing goes, oh, okay, well, you're really at, it interprets that is that you're at 200 degrees. Okay. That's what it's going to then send to the computer. It's going to basically send the computer what it thinks is going on, not necessarily what is going on. Okay. Sometimes what would happen on cars, guys, is you might disconnect this sensor. In fact, that's one of my common tests for diagnosing failures, is I'll disconnect the sensor. And when the computer sees that the sensor is totally disconnected, he goes, what? Oh, there's something wrong. And then a lot of times he'll substitute values. Well, I've disconnected sensors, and you think, okay, well, the sensor's not there. The computer should think that now the coolant's like 30 degrees below zero. But you know what it shows me on my scan tool? 200 degrees Fahrenheit, because the scan tool data is interpreted data. It's not real. It's ones and zeros, right? It's what the computer thinks is going on that it's sent to your tool, and then your tool has to then redisplay it, right? So it's interpreted data. The guys at Snap-on, they have some terms for this. They call, if you're testing something with your meter, they call that front door. And if you're testing something with the scan tool, they call that back door. And actually, Snap-on started calling it these names, and then the Bureau of Automotive Repair kind of adopted that. And everybody jokes around about, oh, the scanner's the back door, but the point of it is, scan tool data is interpreted data, and it can lie to you, okay? But here's one of the nice things about OBD2 generic. If you have your tool and you are pulling the generic data, that's the data that the government, the EPA says, okay, we want these things in this generic data mode, it's not supposed to lie to you, okay? So what I'm saying is I could have my Snap-on Solus, and it could be in manufacturer mode, where it's trying to simulate the factory scanner, and I can unplug stuff, and basically I can have the scanner lie to me. When I'm using my OBD2 generic scan tool, it's not supposed to. It's one of the rules is that it can't lie to you. So it should not lie to you in that mode. It could still interpret something incorrectly, but it can't just falsify numbers. Okay. So that's one of the nice things. And so even though I wasn't ready to necessarily get into the specifics of this circuit, I wanted to kind of point out how everything's hooked up. So now that we've done, and then how the scanner's hooked up, back door, how the sensor's the front door, where your multimeter comes into play for testing. So another way you can look at this, and this is another analogy Snap-on uses, is that the scanner is almost like a compass. It kind of gets you the right general direction to go with codes and data, but it's your meter that does your pinpoint diagnosis of exactly what's wrong in the circuit, right? That's how you pinpoint exactly what's going on wrong where, right? Now, is there ways to shortcut things? You better believe there are, and that's how we can make decent money in this field, right? So anyways, with all that being said, I know I have a few of you guys that are maybe a little bit more advanced, and you've been through some other automotive classes. And do you guys want to try to answer this question? How would I diagnose this circuit? Let's say I think there's something wrong with the temperature circuit of the car. Maybe the car's running weird, right? Maybe it's running too rich all the time. So I think maybe there's something wrong with the coolant temp sensor, and the computer thinks the engine's cold when it's really not cold or something. Okay. How could I test this circuit out? What do you guys think? You guys tell me. And you could throw out a guess, like, even if you're wrong or right, it's not like I'm going to beat you up through Zoom. Any ideas? Any directions? Imagine you were you're like, oh man, I think I got a fuel injected car. It's got this temperature sensor. I think there's something messed up with that thing. I have a multimeter and I have my ELM interface. What am I going to do? What do you guys think? Anything? Like, I don't know. Take it to the dealer. All right. When I see something on the chat. I don't know. Okay. Well, couldn't I hook up my scanner? Okay. And I could look for codes, right? And see if there was a code for something about the temperature sensor, right? That would be one way. Okay. I could maybe get some voltage charts and resistance charts, hook up my meter to the sensor and try to measure its voltage and its resistance and kind of follow those factory procedures, right? There's nothing wrong with doing that. That's a good way to do it. Okay. Both of those things would be good. The other thing is I hook up my scanner. I could check for codes. I could also look at the data. And one of the data things I should see, we call each data parameter a parameter ID or a PID. So there should be a data PID that says, hey, the engine temperature is at X amount of degrees. Maybe it says it's 160 degrees, okay? And I could compare what it says on the data to what I really measure with the engine. So here I have a temperature probe that can work with some meters that have the temperature sensing ability. And so I could stick this in the upper radiator hose, like take the hose off, stick this in there, put the hose and clamp back on, and I can measure the temperature of the coolant and then compare that to what my meter says to what the scan tool says, right? That'd be another way to do it and see how accurate that was. Of course, they sell those infrared temperature guns where you can shoot the gun with the laser on it. And instead of having to put the sensor in there, that's a little faster. Okay. But all that is good ways to do it. And it's all kind of slow, okay? In our business, if you're going to be a professional mechanic, time is money. And so I want to figure this thing out as quickly and as accurately as I can without screwing around, okay? So here's how I would do it, okay? Because I have to work fast. I'm going to divide the circuit up into two halves, okay? One half is the actual temperature sensor, thermistor. The other half is the computer and all its wiring over here, right? I'll make this a different color. I want to divide it. It's either the computer and the wiring, which I hope it's not, right? And that could be a problem in the computer, could be a problem in the wiring going to the computer, or the problem could be at the sensor, right? I'm going to take the computer and the wiring, I'm going to throw them on one side, sensor on the other side. So the easiest way to do this would be, hey, I'm going to disconnect the sensor and I'm going to look at my scanner in generic mode. And you know what it should say? it should say, hey man, you're way cold. You should be like minus 40 degrees below zero. Right? You should be screaming cold. Okay. So when I unplug the sensor, then what I would do is I would take, let me change my drawing tool here. I would take a paper clip, and we're going to call that paper clip a J tool. And I'd take that J tool and I'd put it in place of the sensor. So now I have no sensor. It's my paper clip. And don't worry, in this case, I wouldn't like fry anything because there's a resistor built into the computer to protect that circuit. In fact, that's how it knows what the, I won't get into how it's a voltage divider circuit anyways. So I throw my paper clip in there, and now the computer should say, oh man, you're like 300 degrees. You're smoking hot. Okay. Well, if it went crazy cold, unplugged, and if it went smoking hot when I give it the J tool, right, which is our automotive name for a paper clip, if you can't just tell a customer, oh yeah, I threw a paper clip in your car, they're going to think this guy's a crazy man, right? So you say, hey, I used a J tool to retrieve those trouble codes. Or how about in this case, I'd say, oh, I used a J tool to simulate a hot thermistor for coolant temperature to see how the OBD system would react. And they go, oh my goodness, here's $200, right? You got to make it sound good, guys. So we throw that J tool in there and it should say really, really hot. Well, if it does those two things, you know what that tells me? Actually, I don't want to give it away. What does that tell me? I unplugged it. It went really cold. I threw the J tool in there. It went smoking hot. And all I've been doing is looking at the data with my generic scan tool. Okay. What does that tell me at this point? You guys tell me.
The computer's just making stuff up.
No, the computer's not lying to me. It's like when the sensor's disconnected, it went way cold. And when I bypassed it with the J tool and plugged him in, it went way hot. So basically that told me that the wires going to the computer, they're good. The computer's good, and its logic and signals going out to the scan tool, all that's good.
So it has to be the variable resistor.
Yes, it has to be this. It has to be that the thermistor is off. Okay. Now there's a couple variables, right? Like if let's say it wasn't reading right because you didn't have enough coolant in the car, and the coolant wasn't actually touching the sensor, right? I mean, that there's some weird scenarios, but by and large, if you've eliminated the computer side and the wiring side, you've proven that is working correctly. So the problem has to be the sensor, right? Or the sensor side, which would either be the sensor or what the sensor's touching, right? The coolant. So I would say, okay, boom, I'm throwing a new sensor in there. And of course, I would check the coolant level before I did that. But, that's how you can split these things up really quickly. And so, I used OBD2 generic data. And actually, in this case, in this scenario, I would use that and I would not use the factory tool. Why? Because this tool will lie to you doing this exact test. Okay. And remember, in OBD2 generic mode, it's not allowed to lie to you. Okay. So again, I just wanted to use this as an example. You could think of this as like your tech tip of the night of the power of OBD2 generic data in a scenario where you would use that, and you could do a good diagnosis and not mess around spending a lot of time. Okay. All right. So if I clear out my things, we went over a lot of this stuff the last class. Why did we end up with OBD2? Well, we started doing loaded mode testing through the state of California and a few other states. And we started figuring out there was all these failures, but there wasn't really a way for the customer to realize that there was something wrong with their car. And so the whole idea was that we wanted the check engine light on the car. If I come back to the should be a check engine light here somewhere. We wanted the check engine light on the car to be related to, hey, there's a problem that's going to impact emissions. So, so we set up criteria to do that. So earlier tonight, I was talking about, hey, I want you to leverage your OBD2 generic information. If you look at what's on the screen right now, this kind of old school scanner menu, this is like your OBD2 generic functions. You basically had 9 modes that the government mandated that the car manufacturers give you. And those 9 modes were what you see on the screen here. They said, okay, man, we want you to be able to give the technicians, give them the ability to pull trouble codes from the computer. Okay, so that was one of the modes. And then they said, we don't want just codes. We want you to be able to look at data, certain data parameters, certain data PIDs that you could see, okay, I got this code. Does the data support that code? Okay. Now this third thing was totally like kind of new for OBD2. And actually, I circled the third one, but I wanted this one. This was a new thing for OBD2, and it was a big deal, and that was freeze frame. So what that meant is when I set a code, the very first code I set, I take a little snapshot of how was the car running when the code was set. So if the car was a cold engine at, let's say, 54 degrees, and it just fired up, it only run 30 seconds, and then the person was accelerating at 30 miles an hour, I want that information stored, and that was the freeze frame. Okay, so they came up with these basic test modes. Some of them we had before on some cars, some of them we didn't. Some of them were really a new idea, and that was pretty cool. What you'll see is if you happen to be working on a 94, 95, it might have some of this stuff in its diagnostic system, or it might not. Okay, some manufacturers, it was all they could do to make what the government wanted to do, like the bare bones stuff by 96, because they just didn't, they hadn't invested that much into a self-diagnostic system in their vehicles. Remember that the players involved in setting these standards were the EPA, Environmental Protection Agency, and CARB, California Air Resources Board. And then they worked with the engineers that build the cars, right? The SAE, these are the guys that actually build the cars. And of course, they had all kinds of meetings, and this started back in the late 80s. And that's what laid the groundwork for what the standards became in 1996. And so what that also means is that there was some variance between a California certified car and a federal certified car. And in the early days of OBD2, the differences could be quite a bit. So the federal car could be much more bare bones on what its system could do versus a car that was built for California. California, you know, they've always been kind of a leader in emission stuff. And they said, nope, guys, we want you to do this, right? And it's like, well, look, we're a big market, right? California is like, if it was just, if California was its own country, it's like, what, like the 5th largest country or something. I mean, it's a huge state within our country, right? And we're such a big market here that we can kind of call our own shots. And we saw this very recently. We had a difference of opinion between the federal government with a different administration in there and California on what they wanted the fuel economy to be, right? And California said, no, we don't care. We want you to keep pushing the limit and get better and better and better fuel economy. So anyways, when it comes to diagnosis, what you're going to find is there's going to be a lot more built-in diagnostic stuff in a California certified car, especially in the early days. Okay. Now that we're in the, 2020s, there's not a whole lot of difference between a California certified and a federal certified, but back in the mid to late 90s, the difference was significant. Okay. So we'll get rid of some of those scribbles and keep going. So what did OBD2 give us? Well, a lot of the terms I'm using right now are OBD2 terms that they weren't even standardized before then. So common terminology, like for instance, calling the check engine light the MIL for malfunction indicator lamp, calling codes DTCs, calling a coolant temperature sensor, calling it the ECT for engine coolant temperature. Those were all standard terms that came about with OBD2. Related to that, like what the heck do you call the computer? Well, before OBD2, you called it, you know, whatever you wanted. Ford called it an ECA. A lot of manufacturers call it a CPU. GM called it the ECM. Over time, the standard term through OBD2 became that's the powertrain control module, or PCM. Okay, we ended up with standard diagnostic codes, new monitoring emissions, so that, you know, created more stuff for us to worry about. But I'll tell you, a lot of these other things were really good, and so I could take the bad here with a little bit of that good. So, you know, there's two sides to this thing. Some of this stuff's a pain in the butt, right? Like you're fighting an EVAP monitor. Yeah, it's frustrating. But remember, you also got standard terms and codes and stuff. And before that, we were all over the place. Okay, so here's some of these standard terms. Data link connector, that's where you hook up the scan tool, right? GM used to call that the ALDL connector. Ford called it the star connector. I mean, it was all over the place. Okay, now it's the DLC. O2S is your oxygen sensor. ICM is your ignition control module. And your scan data, all your scan data parameters are now called PIDs. Okay, so part of what we're doing here is just trying to get through these standard terms so we're all speaking the same crazy acronym language here on our cars. I'm going to point out this one right here. This was huge. Most manufacturers, other than General Motors, and of course, remember, we use GM as a basis for a lot of the stuff that became OBD2, because their built-in diagnosis system, their OBD system, their OBD1 system was really way better than most other manufacturers in the mid 1980s. I mean, they were just so much better. GM would give you some fuel trim. Most other manufacturers really did not. And this was one of the standard things with OBD2 is they would give you short-term fuel trim and long-term fuel trim. So that was huge in there. All right, moving right along. All right, so scan tools, OBD2 required, it required a scan tool to play toys, to get all the cool stuff. You had to have a scan tool now, right? Nowadays, of course, we have little interfaces with our cell phones and all kinds of PC-based tools. In the 90s, you had, you know, more like plug-in tools like the one I have here. Well, that's a fairly new one. That's actually a tool that you'd find sold at Napa, and it's not a bad little scan tool. Anyways, I have on here no more flash codes, because in the OBD1 days, it was pretty common to figure out if the computer had set a code, and what code the computer had set. You would have to take a paper clip, right? You'd have to take a J tool, stick it in a special spot, and count the flashes. And it was crude. It was like 1, 1, 2. Oh, okay, that's a code 12. But on a different type of car, a code 12 could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? And then it would cycle over again and you get all messed up. Well, wait, was that 12 or was that 24? So no more flash codes. We now have a machine that's going to talk to the computer and tell us what the codes are. And that was really a huge leap forward for a lot of manufacturers. You were still counting flash codes, and flash codes, you know, sometimes you could read them right, and sometimes you couldn't. And they were all over the place. If you had like a Honda, you would have to rip off the carpet, and there was a little light on the computer and then you would turn, you count the flashes of the little LED on the computer box. So, it was craziness. But the nice thing about the scan flash codes is you didn't necessarily need an expensive tool to pull the codes. Well, guess what? Now I needed an expensive tool to pull the codes, but man, I could sure get a lot more than just some codes out of this thing. So it really was a step in the right direction. Okay, so I was looking at this on that scanner screen I had earlier, and I decided to wait before I jumped into all this stuff. These are the actual test modes for OBD2 that were like the basic ones by the end of year 2003. There is, and so these are the ones we're going to focus on. There is some new modes like 0, 0A, and we've started going to letters and stuff. Some of you guys might get freaked out about the dollar signs you see over here. This doesn't relate to money. Like, oh, if I'm going to mode 9, that's the big bucks. That's hexadecimal computer language. Okay. And the reason I have that on the slide is on some scan tools, when you go and pull generic data, you see some of this hex code still. And so that's just like computer programming stuff. Don't let that freak you out. These were the generic modes. Okay. So 1 through 9. Okay. So again, you had, data stream, that's your PIDs. You had your freeze frame data. You had the ability to read what the codes are. You also had to have the ability to clear those codes. Okay. A new one was, hey, give me information about the oxygen sensors. Because we no longer just tested them to see if they were shorted or they were open. Now we test oxygen sensors to see, are they working good enough so that the emissions are low? Because remember, a big part of OBD2 is focused on the smog, right? What's the smog coming out of the tailpipe? Well, it's not practical for me to have like a exhaust gas analyzer plugged into the exhaust pipe of the car as I'm driving down the road everywhere, right? That would add like $5,000 to the price of every car. But what I can do is indirectly see what the emissions are. So if I test the oxygen sensors and they're testing good, well, guess what? The emissions of the vehicle should be low. If I can test all the various emission control systems, we call this non-continuous monitors. So things like your catalytic converter, if I can test that thing, and I can test the EGR valve, and I can test the EVAP system, and I basically can test the vast majority of the emission control devices on my car, and the emission control devices all test good, and the engine is running well, guess what? The emissions coming out the tailpipe, the smog, should be low. And so that was kind of the idea. So mode 6 is non-continuous monitors, things like the catalytic converter test results. Okay. Mode 7 is continuous test results, and that's things that it's testing all the time. So some things it wants to look at all the time, like for instance, are the sensors, are they shorted? Are they open, right? Are the sensors really screwed up? I'm going to check for that all the time. Is the car having a misfire? I'm going to try to look for that all the time. Do I have a major fuel trim issue? I'm going to check for that all the time. So those are the things that it's always looking for. Those are the problems it's always checking for or monitoring for. Okay. Mode 8, control of onboard tests. This is, can I use my scan tool to control the car in a special way and get it to do something? This usually relates to an EVAP, evaporative emission control system test. Okay. And then mode 9 is about the vehicle information. This is, tell me what the VIN number of the car is. Tell me what the calibration is in the computer system. Okay. And you think, well, why is that a big deal? Well, I've had mode 9 save my bacon a couple of times. Now, I know some of this stuff, like I'm throwing out stuff really, really quickly, right? I'm trying to like not keep you here all hours of the night, we will go over this again and again and again. And don't forget that you have access to this presentation. And of course, you'll have access to the video and stuff as well. Mode 9 allows you to get the vehicle's VIN number off of the computer. And I'll relate this to a story. I had a car a student brought in, and they're like, yeah, I can't get it to run right. And they can't figure it out. And it's been through multiple classes and what's going on. So finally, at some point, I said, well, it's weird. It definitely, it's like, it's a V8, but it's not running on all 8 cylinders. It's running on 6 cylinders. And the other classes are like, yeah, there's something wrong. It's not turning on the fuel injectors for all the cylinders. What's going on? That way, if we think we have injector driver issues, and the student's like, I've already replaced the computer. So I go to mode 9 and I pull the VIN number, and guess what? The vehicle identification number that's programmed in the computer does not match what's on the car. And so then I'm like, well, this computer is not for this car. Where'd you get this computer? What's going on? Oh, I went to Pick and Pull. I grabbed this computer. Well, guess what? You grabbed a computer out of a V6 and you're trying to get it to run a V8. Yeah, everything plugs in, but it's not going to work right. It doesn't have the driver circuits to fire those other fuel injectors. So the reason mode 9 is important is because sometimes you got to make sure that you have the right parts in the car, the right computer, or the right program. Maybe somebody's reflashed this computer. And I had this come through when I was working as a real mechanic, come through shops, and they're like, yeah, this car keeps failing emissions. It's got too much NOx. And you pulled the information. It's like, oh, well, that's not the right program. Somebody has reflashed this thing. They put in a performance program. And so, yeah, it's going to produce more emissions. Of course, it's making more horsepower, but now it's failing emissions. So anyways, these are the basic modes of OBD2. And you can do a lot with these basic modes, okay? This tool, not with the free app. I think the free app, it can't do mode 6, but it can do all the other modes. And so that's a lot of stuff off of a free app with your cell phone and an interface that you could buy for 25 bucks. So we actually looked at this a few weeks ago. Of course, that's the Snap-on Solus Ultra. This screen, it happens to be graphing out some data. It is really nice to graph out the data. It just makes it easier to see over time, right? We talked about how your different data parameters, we call those PIDs, right? Parameter identification. So if I go back, it's kind of hard to see in this. What you'll notice is I've entered in a specific vehicle. This is a 2003 Cadillac Seville STS. So this scanner is not in its generic OBD2 mode. It's in its manufacturer mode where it's trying to simulate the factory tool, right? And I can tell that because I've actually programmed in what vehicle it's working on. And I have some different PIDs here that you don't normally see OBD2 generic, okay? A lot of this stuff takes a long time to figure out what it is. Although these days, you can Google search a lot of this stuff. If you're like, hey, what the heck is the TCC? Okay, well, that's the torque converter. That's the torque converter clutch. And, so Google can help you figure out what the definitions are. But what we're looking at for this thing on this particular page is we're looking at data PIDs related to what the torque converter clutch is doing for the automatic transmission. Anyways, so those are all these different things. TCC slip, the duty cycle percentage, that, those are all PIDs. Okay. So I said this a couple weeks ago, and I want to make sure I hammer this home. When the mill is on, the way I want you to think of this is, oh, the dude in the dash, he's not happy about something. It's failed a test of one of those monitors and he's upset. That's going to impact the vehicle's emissions, and he's turning on the light to let you know there's a problem. When the light is on, that means, hey, he set a code. And if it's a OBD2 car, you'll be able to retrieve that code from the computer's memory. Because when the light's on, man, the code's there. Not only will you get that code, but he would also have a freeze frame. So it'll show you when the code was first set. Okay. I think I said this earlier tonight. The scanners are like a directional tool. They kind of point you in the right direction. You might still need your oscilloscope or a DVOM or a multimeter to actually pinpoint the actual cause and pull in a wiring diagram. And that's why like the 181 class does work well with this 188 class, because you kind of use these guys together. We've already talked about this, right? Front door and back door. The scan tool is your back door tool, right? Because it's getting scanner interpreted data. Okay. Here is a look at the diagnostic connector for OBD2. This became standardized in 1996. And so when they talk about the 16-pin connector, one thing I want to point out to you guys is that, yep, there's 16 pins on this connector. Okay. So, we're going to open it up for another tech tip. Okay. The tech tip is, hey, let's say I hook up my scan tool and it doesn't communicate with the vehicle. Okay. Well, what do you do in that situation? The easiest thing to do, and I hate to say it, but the easiest thing to do is try a different scan tool. Okay. So let's say you hook up, you get this tool and you go and you hook it up and you're not pulling data. You're like, oh man, what's going on? You know what? Go to the auto parts store with your car and have them do that free code read with whatever scan tool they have and see if their scan tool communicates with the car. Because the problem could be your scan tool. And so that's why a typical automotive shop will have like 3 or more different scan tools. And I think even for you, if you become a professional automotive technician, you might buy some $5,000 scan tool at some point in the future. But having this little generic OBD2 interface is still worthwhile, because there might be a time where you hook up that $5,000 scan tool and it doesn't communicate, and you need to see, well, what's going on? Having another tool to plug in there is really helpful. So if you ever have a communication issue, first thing, try a different scan tool. Once you've tried a different scan tool and you're still not communicating, some knowledge of this connector is important. And what I want to point out for you guys tonight is that on pin 16 here, I have battery power. So I need to have battery power right there going to the scan tool. And then I need to have ground on pins 4 and 5. So if I've tried a couple of scan tools and they don't communicate, my next step is I'm getting out my meter and I'm checking these pins 16, 4, and 5 to see if I have power and grounds where I'm supposed to have power and grounds. Okay. That's really important. The last thing I want to say is, if you looked at the back of the connector, you might notice, hey, there's not wires going to all the pins. Maybe it only has pins on 5 or 6 wires, and that might be perfectly normal. See how there's a bunch here that say vendor option. That's the car manufacturer. It means that they can do whatever the heck they want on these pins. Okay. They can use them. They can not use them. They can whatever. Now, what about these pins? You guys tell me. Have you heard these names before? J1850, CAN, ISO, anybody? What do you think? Does that sound familiar? We did talk about that a little bit, but it was a few weeks ago. All right. Well, it's getting late. Your brains are probably fried. I'm starting to ping a little bit myself. These are, ooh, I got something in the chat. All right. Brains are dead. All right. These are different communication protocols. Remember how I talked about the computers speak different languages and your scan tool needs to be able to be bilingual, right? It's we talked about like C3PO is a protocol droid, right? There's different communication protocols in different vehicles depending upon the year, depending upon if it's an import or a domestic or whatever. And so the different communication protocols actually would speak on different pins of the DLC. So if I have an older, like my pickup truck is an old GM, so it's a J1850 car, it's going to be speaking its language on pins 2 and 10. Okay. But if I had a more modern car, if I had a CAN car, oh, well, that's going to be speaking his language on 6 and 14. Okay. So I guess what I'm trying to say is that remember that there's different languages that are spoken between the different vehicles. And so if you had like a scanner and it won't communicate, maybe it just doesn't speak that language, right? And that if you look at the back of the scanner plug, the DLC is what it's appropriately called. You'll notice that there's not going to be wires going to all 16 of those pins because, you know, it varies between car to car on what communication it's going to be using. But there are going to be a couple standards, and that is that you're going to have power going to pin 16. You're going to have grounds on pins 4 and 5, and a couple other wires are going to be whatever communication protocol it's speaking. Okay. So at the very least, you're going to have 1, 2, 3, 4, 5 of these things being used. Okay. All right. Let's see where that leaves us, because it's been an hour. You guys are tired. I'm getting tired. I just want to make sure I give you enough stuff like you feel like you're getting your money's worth out of this deal. We'll clear my scribbles. Remember we talked about front door, back door. We're going to test the front door with our meters and stuff. Back door is our scanner diagnostic data because it's interpreted data. It's not live data. We talked about vehicle networks a couple weeks ago, and I said, hey, modern vehicles are very, very much networked, and you can have weird things take stuff down, right? I think I gave you my example where I was working on a Corvette, and what was the driver's side power window switch was preventing the car from starting. Why? Well, because that's not just really a window switch. That was a module, a computer on the network, and it was bringing down this network. So if your car's computer network gets shorted down and these computers can't talk to each other, guess what? Car's not going to start, or it can do all kinds of other weird things as well. So that's what that was about. And of course, we did talk about that a few weeks ago. And, you know, stuff that you wouldn't think is related is now related on a modern car because of the way everything's networked together. And we also looked at this and we talked about how there's typically one computer on the car. And remember, another name for computers are modules, okay? There's going to be one computer or module on the car that maybe is the protocol droid, if you will. He's the gateway module. He speaks several different languages, and then he's either going to communicate to the scanner by J1850 or CAN, which stands for Controller Area Network, or ISO. So there's really only like a handful of protocols that this needs to speak, but the car could have all kinds of weird stuff going on. It could be, you know, could have stuff speaking UART and most bus, and there could be, you know, 20 different languages from all these subsystems that the gateway module needs to happen. If you had a gateway module failure, that's, likely the car's not going to start, and you're probably going to get no communication with your scanner. All right. And so that's kind of the, where we ended up finishing this thing. Oh, I will say, we've been kind of dancing around this all night, but if you take a scanner like this Snap-on or an OTC, any of your professional based scan tools, right? They have two sides to the tool. One side of the tool is the manufacturer side, where you put in the year, make, model, all that stuff. You maybe have to plug in the VIN number, and what it's trying to do is to simulate the factory tool, okay? The other side of your tool that we're going to focus on a lot more is the OBD2 generic side, where maybe you don't get as many bells and whistles, but guess what? It's not supposed to lie to you. And there's still a lot of stuff that it can do there, right? Pull the data stream, the PIDs, codes, what's your freeze frame, what your monitor's doing. So there's really a ton of diagnostic information there. All right. And this is kind of what I just said, right? Maybe you got an issue with your scan tools, so you always try a different scan tool if you get a communication issue. And if you've tried multiple scan tools and it's not working, then I'm looking at my pins, right? Because maybe I have no power or ground, or the pins are all loose or something like that. All right. That kind of brings us, oops, hang on a sec. I clicked the wrong thing. And that brings us kind of full circle on all this stuff. So anyways, all right. So yeah, that's probably a good spot for us to stop. What we'll do on our next class, and we won't have class. We won't have class for 188 next week. We're gonna end up skipping a week. But when we do come back, what we'll get is into some actual OBD2 specific stuff, and really get into like the different codes and the architecture and what are the conditions. And we'll kind of finish this thing up. I mean, we're almost done with it, but I kind of feel like you're fading, I'm fading, and we don't need to push that envelope tonight. So I've given you a couple great tech tips as far as like using your J tools on sensors, and how this OBD2 generic won't lie to you, and how to diagnose communication issues. I think what we'll do then is we'll change this share and wrap this thing back up to our actual Canvas class, and show you like, well, what should you be doing? Well, you don't have anything to do for a while, but if you want to get started on some stuff, right? The presentation, you could always get the safety test done, right? All the basics. We're going through this presentation right here, right? So you could look through that presentation, do some research, figure out, do I want to buy my own OBD scanner adapter or scan tool, or do I want to rent one from the school? Or not rent one, but check one out from the school. If you want to check one out, remember, you got to email me. We'll get that going. I have info on ShopKey Pro. If you get a scanner and get going, like, you're not going to hurt anything by, getting in your driveway and turning your key on, engine off, plugging in your scan tool, and trying to pull some information. Try to go through the different test modes. Pull mode 1 data, pull codes, pull data, and see what you can see, and just kind of hunt around. Okay. You can also, if I get rid of that stuff, you can also cruise through the Snap-on training, and this will kind of line up with what I was talking about tonight, and then give you, you know, that the perspective that's specific to Snap-on, okay, and what their tool will do. And so if your goal is to buy like a really nice scan tool, if you go through all the Snap-on stuff, you're going to see what that Snap-on tool can do, and so you can compare what tool you're looking at versus the Snap-on, which is one of the most popular tools out in the industry, okay? And then you could go into some of this advanced stuff. I don't want you to go too crazy, but if you were going to do anything on this area, this is what I would do right here. The CDX Pro work, which is pretty rad. So we got the, basically I've cherry picked some stuff out of the engine performance section. So if you choose to buy the CDX book, this is some good information, and it asks you to do some stuff. And so we'll end with our demo tonight is what can I do in CDX related to scan tools? And this is pretty cool. So let me go into it. Now, I was in the electrical section earlier, but scan data stuff is part of what they call engine performance. So we had to move to this engine performance ASE area 8 air stuff, okay? And if I scroll down here, what you'll see, there's all kinds of information, but there's one in particular that's about onboard diagnostics. So I'm going to check that one. And I'm going to scroll down here, and there's just a ton of good stuff. I'm going to skip to the media gallery so I can get to some of the cool stuff there is in here. But there's just a ton of stuff. Okay. For instance, I'm going to click this scanner animation. And let's say you're like, oh, I don't have maybe you have limited access to an OBD2 vehicle or something. This thing simulates a scanner, okay? So check this out. I have to hook it up, right? So I had to plug in the diagnostic adapter to the OBD2 connector, which is supposed to be located within 2 feet of the instrument cluster, okay? Oh, in order to get it to communicate, I actually do have to turn the car on. So right now I have a key on, engine off, okay? And I'm gonna go in, and this is the manufacturer mode. This is the generic OBD2 mode. I'll click that one. I'm just gonna hit search protocol. It's gonna try them all. Okay, it figured it out. And you can see I got my 9 generic modes. So you can kind of play around with this thing. Let's say it generates a fault code. Now on a real car, what I could do is I could unplug my coolant temperature sensor, key on, engine off, and that would generate a fault code, okay? And then it's like, okay, well, I want to, what's that code? Okay, let's read them. Oh, it's got a P0301. That's a misfire for cylinder number 1. Okay. And, you know, I could say, okay, well, let me start this thing. So now look at the tach. This thing's running now, right? And then this took me a while to figure out. This is your throttle. So I'm going to rev it up. I'm neutral dropping it. I got it revved up. Oh, it won't. Oh, no, I can't do that. I got to bring it down. I got to put the brake on. Now I can put it into drive. Now I'm going to let off the brake. Boom, and I'm flooring it. Boom, so now I'm hauling, right? Look at that, 60 miles an hour, 80. Top speed in this thing. How fast is it going to go? 100. This thing's flying, right? Oh, now I'm climbing a hill. I'm losing some speed. Anyways, so you can kind of, you know, drive this thing around, so to speak, and look at the data. And it's pretty cool. There is an issue with the car when you generate the fault code, and you know, you can play around with that and see if does that make sense or not. Like, Did they do a good job programming this thing? Is this a realistic scenario or is it not? Okay. And we'll get more into that stuff as the class goes on. So, you know, if you're choosing to buy the CDX book, you don't need to have this. But if you play around with this stuff, it definitely will add a whole layer of other information to the class, and you will learn a lot more from it. So if you haven't done like engine performance classes and you want to know, well, how do those sensors work? Like all that stuff is built into CDX, and so you can learn a lot by playing around in here. So you might, if you purchase CDX, you might want to start by going through the CDX activity and then going through the Snap-on stuff. You have a couple different ways that you can go on this. So anyways, I hope that makes sense to you. Let me put the brakes on and put her back in park. I hope that makes sense to you. I hope, you know, you got something out of the night. You learned something. You have a little bit of a direction on the class. Fear not, as we get through this thing, and we're doing some of this stuff in the, whether it's the Snap-on Solus stuff or we're doing some of this advanced drivability diagnostics. I mean, that is pretty darn cool stuff that not everybody knows how to do, and you're gonna like it. Okay, so again, nothing's due right away, but if you have time, you know, instead of watching, you know, like, I don't know, drifting videos or playing video games, you know, start going through some of this stuff. There's a lot of good information in here, and you'll get a lot of info on this thing on how to do good vehicle diagnostics. Start shopping around for scan tools or interfaces. Contact me, send me an email if you want to check one out from the school. And we won't have a session next week. We'll probably get back going maybe the week after that and do another one of these Zoom sessions to give you guys some more information and kind of keep you moving forward through the class. Okay. Any before I let you go for tonight, any last questions for me? I'm looking on the chat. I don't see anything up on the chat. So remember, no communication, try a different scan tool, right? And if you're like, well, I only got this little interface, like I said, go to O'Reilly's or AutoZone. All those parts houses will say, hey, we'll check your codes for free. Well, if their code reader can talk to your car and pull codes, that tells you that it has the ability to communicate, and your problem would be your scan tool, right? But if their code reader can't talk to your car, neither can this thing, then you're pinning your deal out, right? And then never underestimate the power of the J tool. So, all right, guys. Well, thank you for being with me tonight. It's really been a pleasure. And I'll let you go from there. Okay. You have a good couple of weeks. Stay safe out there. You know, keep learning and keep having fun. Okay. We'll catch you next time.
Good night, Mr. French.
Good night.